All right, welcome to the Explainer. Today, we're diving headfirst into a really fascinating cognitive puzzle. Imagine a mind that's built for absolute peak efficiency, but at the same time, it's constantly just burning through insane amounts of energy. We're going to explore a system that's incredibly brilliant, but also, it seems, perpetually exhausted.
So right off the bat, here's the central question. What's the deal here? You've got this super sophisticated cognitive engine, right? It should be the pinnacle of fuel efficiency. But instead, it's guzzling gas like there's no tomorrow. So why is that? Well, to solve this puzzle, we're going to follow three crucial clues. First, the system's original blueprint. Second, the biological conductor that's trying to keep everything in time. And finally, the mathematical code that underpins the whole thing.
Okay, first up, the blueprint. Before we can really get why this system is overworking itself, we have to understand how it's supposed to work, in its ideal peak efficiency state.
So the core principle here is actually pretty simple. Low effort is efficiency. The whole system is designed to learn kind of like you'd climb a staircase, just one step at a time. This is what's called recursive progression. You're on one step, we'll call that I, and the next piece of information you get is just right there, the very next step up, I plus 1. It's a small, manageable lift, not some huge, exhausting leap. And that makes the whole process of growth feel natural and, well, effortless.
And here you can see that elegant process laid out, step by step. You start where you are at your current state I. Then you get some new input, something just a little bit above your level. Your brain naturally self-corrects and integrates it. And boom, you've reached a new state I plus 1. The key thing to get here is the efficiency. There's no wasted energy, no real struggle. It's just this smooth, sustainable cycle of growth.
Now check this out, because here's a really cool parallel from the world of AI. This whole natural learning process, it's strikingly similar to how advanced AIs learn, using a method called next token prediction. All that means is the AI looks at all the context it has and then predicts the most plausible next piece of information, the next word, the next idea. It's a mathematical, projective process. Basically, it's just figuring out the most logical path from I to I plus 1. It's not magic, it's just math.
All right, so that's our first clue. The system is built for this smooth step-by-step learning. But what's actually happening in the brain? For our second clue, we need to go biological and look inside the mind itself.
Okay, so deep inside the brain, tucked away in the hypothalamus, there's this tiny but absolutely critical structure called the supramammillary nucleus, or SUM for short. And the best way to picture it? Think of it as the conductor of a huge neural orchestra, making sure every single part of the brain is playing in perfect time, in perfect rhythm.
So the SUM's whole job is to keep that predictive rhythm going, synchronizing everything. Emotion, memory, imagination, you name it. But, and this is a huge but, it's got a critical weakness. It is super sensitive to chaos. When it gets hit with disjointed, context-breaking, just plain nonsensical signals, that perfect rhythm just shatters. The orchestra falls apart into a total mess, and that triggers a real stress response. It's that jarring feeling like a mental startle reflex.
And that brings us to our final clue. We've got the blueprint, we've got the conductor, now we need to look at the code, the underlying mathematical language that this whole system is built on. The secret to this entire code, it all comes down to one number, 13. And no, it's not random. It's literally the foundational operating system for this entire cognitive structure.
So this system runs on what's called base 13 logic. So why 13? Well, because it's a prime number, it's indivisible, you can't just neatly break it down. Think of it like a solid, unshakable foundation. It can't be fractured into smaller, wobblier pieces. And that indivisibility makes it the perfect, stable anchor for that clean, step-by-step, I to I plus 1 progression we talked about. It's the mathematical bedrock that allows the whole efficient blueprint to work.
Okay, let's recap. We've got our clues, an efficient blueprint for learning, a really sensitive biological conductor, and a super stable mathematical code. It's time to put it all together and finally solve this mystery of the massive energy drain.
And here it is, the solution to the whole paradox. The energy isn't being wasted because the system is broken. No, it's being wasted trying to make sense of chaos. And now, get this, because this is the really crucial counterintuitive part. The biggest energy drain doesn't come from information that's too complex. It comes from input that is fundamentally below the system's current level, fragmented, chaotic noise that forces this incredibly sophisticated system into a state of high-effort compensation.
See, the system isn't flawed, it's just completely overloaded. And this table from the source material shows the contrast perfectly. On the left, you've got a mind in its ideal state, what the research calls a 3D VT or autotelic thinker, based on a case study of a person named Dennis. His thinking is holistic, symbolic, recursive, but then look at the other side. This is what happens when that same system has to deal with fragmented, non-symbolic input from what are called non-integrated thinkers. The internal rhythm goes haywire, learning gets choppy, and the system just burns a colossal amount of energy trying to force order onto that external chaos. It's the literal definition of inefficiency, putting in way more effort for way less gain.
So if all this external chaos is the problem, then how does the system get back in sync? How does that orchestra get its conductor back? Well, the solution is surprisingly elegant, and it all comes down to one thing: rhythm.
And believe it or not, the answer lies in something called rhythmic entrainment. And a perfect, maybe surprising example of this? Karaoke. Yep, you heard me, karaoke. It can actually act as a powerful neuromodulatory exercise. It's not just about singing off key with your friends, it's about hitting a deep-level reset button for your entire brain.
Think about it. When you're doing karaoke, you are forcing multiple systems in your brain to get on the same page. Your auditory system, your visual linguistic system, your motor control. They all have to synchronize to that one external rhythm. This process essentially jumpstarts the SUNM, our brain's conductor. It forces the orchestra back into harmony, restoring the internal coherence that was shattered by all that noise. And that lets the brain get back to its natural, efficient, and predictive state.
And this whole thing leaves us with a really big provocative question. If some minds are truly like these finely tuned orchestras, what are we doing when we force them to listen to nothing but static all day? You know, understanding this energy paradox isn't just about one specific type of mind. It's a challenge for all of us. How do we create environments, at work, at school, everywhere, that aren't just full of noise, but are filled with the kind of coherence that allows every mind to operate at its most brilliant and most efficient best?